So here we'll take a look at number 4, part A from 2004, AB for response, form B of the exam. This is a situation where they provide us with a graph of a derivative. So here's a graph of f prime, and various points on the graph are already given to us here. So basically what we know from this point, 1 comma 0, being on the graph of f prime, is that the value of this graph, which is again a graph of f prime, when x is 1, so f prime of 1 is going to turn out to be 0, right? We know that from this point being on the graph. So this is a graph of a derivative that we have over here. So when we need to know values of the derivative, we're going to have to refer to this graph. We only have the derivative provided, the graph of the derivative provided on the closed interval from 1 to 5. We are told that f prime, the graph over here, has horizontal tangents at two x values, 1 and 3, and we're also told that the function f is twice differentiable, meaning that the value of the second derivative is going to exist everywhere between -1 and 5. They also tell us that f of 2 is 6. In part A of this question, they want us to find the x-coordinate for each point of inflection for the graph of f, and then give a reason for our answer. Well, we have a point of inflection anywhere where we have a change in concavity on the graph of a function. And a function is concave up when its second derivative is positive, so second derivative positive, we're concave up. Second derivative being negative, our function is going to be concave down. So if we see a change in the sign of the second derivative, positive to negative, negative to positive, we know we're going to have an inflection point at any value of x where that happens. So what we need to think about here is if we need to build a sign chart for the second derivative, which is what I'm going to try to construct down here, and we're only going to be able to build this sign chart on the closed interval from -1 up to +5. If I'm looking at the sign of f double prime, sign chart for the second derivative, I'm going to need to know where my second derivative is equal to 0, and I'm going to need to know where my second derivative is undefined, because those are the two types of points where the sign of the second derivative could potentially change. And if you think about this, the sentence at the end of the problem statement, the function is twice differentiable. If the function is twice differentiable, the second derivative is always defined between these two x values. So we're not going to have any places where the second derivative is undefined. But there will be places where f double prime is equal to 0. This is a graph of f prime. The derivative of f prime, the derivative with respect to x of f prime, is going to equal f double prime. And the derivative, when we are thinking about the derivative of something we see graphed, we should hopefully think slope of the tangent line. So on the graph of f prime, which we're looking at right here, we need to look at slopes of the tangent line to determine values of f double prime, since f double prime is the derivative of what we have graphed. So I know that we have a horizontal tangent line at the x value of 1 and at the x value of 3. They told us that in the problem statement. Well, a horizontal line has a slope of 0, and since the tangent line is going to be determined by the second derivative on the graph of f prime, we can go ahead and say that the second derivative is equal to 0 at the x value of 1 because of this horizontal tangent, and the second derivative is equal to 0 at the x value of 3 because of that horizontal tangent. So the two places where the sign of the second derivative could potentially change are the x values of 1 and 3, the two values where the second derivative has a value of 0. Now what's the sign of the second derivative in between -1 and 1? Well, we just said a minute ago, slopes of the tangent lines on the graph of f prime will give us values of f double prime. We have positive slopes on this piece of the graph right here. Positive slopes are going to indicate a positive value for f double prime on that interval. In between 1 and 3, look, we have negative slopes as we go from this point on f prime to this point on f prime. Since we have negative slopes for the tangent line, we know that f double prime is negative on that interval, and we're back to having f double prime be positive on the interval from 3 to 5, since we have positively sloped tangent lines again on that piece of the graph. So since we have a sign change for the second derivative as we cross the x value of 1, and another sign change for the second derivative as we cross the x value of 3, what we can conclude is that our function f is going to have inflection points in two places at the x value of 1 and at the x value of 3. We know that because the second derivative changes positive to negative at 1 and negative to positive at 3. So the concavity of the function is going to change at those two x's. And it did just ask us for x coordinates. It didn't also ask us for y coordinates, so this wraps up part A.